Okay, today we are going to talk about implicit differentiation. What I'd first like to ask you is, what if I asked you to take the derivative of this? It is reciprocal. You're correct. You said the derivative is 2x plus 2y. Is that what you're saying? Okay, so far, how have our equations looked when we've taken the derivative of them? How are our equations look? Have they ever looked like this before? Okay, so what's different about this one compared to the ones when they do it? Y squared. What else? Okay, before we've had like y equals something, right? And y equals something in terms of x, and we've taken the derivative, right? Here, first of all, we have a y squared, it equals something, okay? So what could be a way for us to figure out the derivative? Could we try to solve for y and maybe go about it that way? We could. Okay, well, what if I had something like this? Could I solve for y here? Probably not. Okay, so we're going to run into some issues. All right. Cole, you were on the right track when you said 2x plus 2y. So even though you thought that that was completely silly, it was not. Okay. When we have equations that look like this here, we have been working with explicit functions. Today we are going to work with implicit functions. Explicit functions are written as y equals something in terms of x. Okay? Implicit functions have x and y mixed in. Okay? It's not solved for x, it's not solved for y. Okay? Sometimes you can solve for y, sometimes you cannot. Okay? But you need to understand the difference between an explicit and an implicit function so we can recognize when we need to do implicit differentiation. Okay. Let's talk about how we would find the derivative of this explicit function. Okay? Our notation was if y equals 3x cubed minus 4x plus 17, then we would write dy dx is 9x squared minus 4. Okay? dy dx, what does that mean? Okay, the derivative of y with respect to x. Okay, that's what that means. Hang on to that. I don't know how you guys are doing. You love math so much that you learn to do it. Okay, so I want to talk about this. If I ask for the derivative with respect to x of x squared, you would say what? 2x. Okay. Now, if I said the derivative with respect to x of y cubed, what are your thoughts? Abram? No, what was your thought? It's okay if you're wrong.
I was going to say 3y squared.
Okay, that is not completely wrong. Okay, the derivative of y cubed, yes, is 3y squared. However, since this variable does not match this variable, we have to think of this as a chain rule problem. Okay? We then have to multiply by the derivative of the inside. What's inside the cube? Y. What's the derivative of y with respect to x?
1. Wait.
Isaac, you said it earlier. What is the derivative of y with respect to x? How did we write that? You gave me the answer of the derivative of y in terms of x. What was that the answer to? Playing Jeopardy here. Can anybody help Isaac remember? dy dx. Okay. If we take the derivative of a term, well, if we take the derivative with respect to x of something that is not x, we have to then use the chain rule. So we took 3y squared, Abram was correct, okay? But then we have to think about the chain rule where we're taking the derivative of y with respect to x. Okay? Does that make sense? When we take the derivative of something that is not x, we have to use the chain rule. So since this was y, we had to multiply by the derivative of y with respect to x. Okay. So, how are we going to find dy dx when we have something like this? Okay. Notice how we have more than one term with a y in it, which means we could potentially have more than one dy dx in our derivative when we take it. Okay? So this is what I'd like you to do when we take the derivative of an implicit function. Okay? You have to differentiate both sides with respect to x, and you have to differentiate every single term. Okay. Yes, this is a new technique, but we still have to remember everything that we learned last week. Power rule, product rule, quotient rule, chain rule. When you take the derivative of both sides every single term, you could potentially get more than one term with a dy dx. It could happen. So if that happens, then you want to move all the dy dx's to one side and everything else on the other side. Then you'll want to get dy dx by itself so you can solve for it. Okay, so if there's more than one dy dx, we're going to have to factor it out of some terms and then divide the rest over. Okay, are you ready? So ready. It is a 4-day week. And then you have a 4-day weekend, and then another 4-day week. How could you not be excited right now? Yeah, you don't have school. Yeah, you don't have school Friday, you don't have school Monday. So 4-day week, 4-day weekend, 4-day week. We gotta be excited, right? Oh, I haven't even updated this. I'll have you put it in the basket for right now, Sharon. Okay. Thank you. Okay. The derivative of y cubed. Abram, what did you tell me that was?
3y squared.
Okay. And then since we're taking the derivative with respect to x, and y cubed is not an x, what do we have to multiply by?
dy over dx.
dy dx. Okay. Chain rule. Inside of the cube is a y, so we have to multiply by dy dx. Okay? Plus, we have to differentiate xy. What do we have here? We have a product. So we have to use the product rule. Okay? So what's the derivative of our first function?
1
Times y plus our first function times what's the derivative of y?
1 dy dx.
1 dy dx. Very good. Equals, what is the derivative of 3x? 3. Plus, what's the derivative of 1?
0.
0. Oh, please do not forget that the derivative of a constant is 0. Okay? So now what we're going to do, I'm going to make this look a little prettier. You don't have to if you don't want to. But I'm just going to write this as y plus x. Okay. So now we have differentiated every single term on both sides of our equation. Now I want anything with a dy dx on one side, anything without a dy dx on the other side. So I'm going to keep these two terms, 3y squared dy dx plus x dy dx. And then since y does not have a dy dx attached to it, how are we going to move it to the other side? We subtract it. Okay. Now, when we take the derivative, our end goal is to have dy dx equal something. Okay? So essentially, from here we are solving for dy dx. How can we solve for dy dx? What does our next step need to be?
Factor.
We need to factor it out. So if we factor out dy dx, we are left with 3y squared plus x. And then our last step is going to be to do what? What do you say? Divide it over. So dy dx is 3 minus y over 3y squared plus x. Okay. When you have an implicit function, your derivative will be in terms of both x and y, more than likely, okay? Since we had an implicit function up here where x and y were kind of intermixed in our function, we're going to have x and y intermixed in our derivative. Does that make sense? Okay. Questions on this example? All right. I have two equations that I've written down. And what is true about those two equations? Huh?
They're equal.
Okay, they're the same thing, right? X times y equals 1 is the same as y equals 1 over x. Do you agree? Okay. The only difference is this one is written how? Implicitly. This one is written explicitly. Okay. So I want to talk about the difference in taking these two derivatives. Okay. Which one would you like to start with?
Y equals 1 over x.
It's like you knew I was going to ask that question. Okay. So if we're going to take the derivative of y equals 1 over x, we're either going to... Okay. Thank you. Some of you have gotten to the point where you think about this as x to the negative 1 in your head. I'm fine with that. Okay. I just think here, what is the derivative of x to the negative 1? Negative x to the negative second. And so sometimes we like to rewrite that as negative 1 over x squared. All right. Let's talk about the implicit derivative. What strategy do we need to use when we take a derivative of x, y? We need to use the product rule. Let me tell you something. You are going to see x times y quite a bit in these problems. So be ready for it. And make sure you recognize that you need to use the product rule. So the derivative of x
1
times
1
y plus x times the derivative of y
equals dy.
equals what? Okay, you seem very unsure. What's the derivative of what? 0. Thank you.
What?
What is 0? Go take it. You have something that let me see if I can. If you have that pass. Probably don't have it. Okay. Be very careful. When there's a constant alone on this right side, sometimes it is very easy for us to overlook the derivative of a constant as 0. So just be careful. Okay? So then we could write this as x times dy dx equals negative y because we can subtract that y over. And then we could write dy dx equals negative y over x. Okay, now, do those look the same? No, but they're probably not going to because one started explicit, one started as implicit. Okay, so their derivatives are going to be a little bit different. However, if we think about y being 1 over x, y is 1 over x, so we have negative y over x, it's going to be equivalent. Okay, we're getting the same thing, it's just going to look different. Okay, the biggest thing with implicit differentiation that we need to keep in mind, okay, is that we have to differentiate every single term. And if you are differentiating with respect to x, and there is a term that is not x, then you have to use the chain rule on that term that is not an x. Okay? For the most part, we're going to see y. All right? But if you happen to get some other variable thrown in there, if we are taking the derivative with respect to a different variable than what you have to apply the chain rule. We're going to see taking the derivative with respect to x, and we're going to see y's thrown in there. Okay, but in general, if you were happen to see another variable, it's going to be the same thing. Okay. There will be a time where we talk about t as the variable that we are taking the derivative with respect to when we get to unit 3. Okay, so we'll have to apply this to t's instead of x's, but we'll worry about that when we get there. Okay. All right, we're going to go to this example. Glad I can make some of you smile on a Monday morning. Okay, is this an explicit or an implicit function? It is implicit. We don't have y equals. Okay. On the left side of our equation, what strategy are we going to need to apply? We have a product. We have 2 sine of x times the cosine of y. Okay, so this helps. Okay, what is the derivative of our first function, Larry?
Just the first part.
Yeah, what's the derivative of our first function that I underlined in blue? What's the derivative of 2 sine of x?
2.
Yes. Okay. Times our second function. Okay. Plus the first times the derivative of our second. Josh, what's the derivative of cosine 1? And since y is inside of that, we have to apply the chain rule and multiply by dy dx. Since we're taking the derivative with respect to x and y was inside, we apply the chain rule dy dx. Okay? What's the derivative of 4? Thank you. Okay, so what we have is 2 cosine x cosine y minus 2 sine x sine y dy dx equals 0. Can I take cosine x and cosine y and write it as cosine squared? No. The angles are not the same. We cannot combine those. Okay? Instead, how do we get dy dx by itself? Two cosine x cosine y needs to be moved over how? Subtraction. So we have negative 2 sine x sine y dy dx equals, we subtract it over, minus 2 cosine x cosine y. Right? Okay. Then to get dy dx by itself, what do you say, Cole? Huh? Divide. Okay, and then we can make this look a little prettier. Negative 2 over negative 2 obviously cancels out. If you left this as cosine x cosine y divided by sine x sine y, that would be fine. But how else could we write it? we could write it as cotangent x cotangent y. Okay? I'm not going to make a big deal if you don't do that, okay? But we can do it. All right, last example. I want to find the slope at negative 1, 2. Okay. When you see slope of the tangent line, or even just slope at a point, what word should pop up in your mind? Which means derivative, okay? When you see slope of the tangent line, you should automatically think, I need to find the derivative. Okay. Now, our function is x squared minus xy plus y squared equals 7. So how must we find the derivative? Implicitly. Okay. Okay. So, Madison, derivative of x squared. 2x. Minus. How do we take the derivative of xy? Product rule. Now, please be careful. We are subtracting a product. So we need to subtract its derivative. Okay? Since the derivative is going to be two different terms, it's going to be in our best interest to put it in parentheses. Okay? This is like the third time we've seen x times y, right? It's not going to be the last time. So, derivative of the first times the second plus the first times derivative of the second. Plus Jake, derivative of y squared. Good. 2y dy dx. Chain rule, since we're taking the derivative with respect to x of a variable that is not x. Equals everybody. What's the derivative of 7?
0.
0. Okay. So let's go ahead and rewrite this to apply that subtraction all the way through the parentheses. So we have 2x minus y minus x dy dx plus 2y dy dx equals 0. Okay. Let's see, what do we do now? Sammy, what do we need to do?
Move the two that have the dy dx to the other side.
Okay, so you're saying you want to move these two over?
Yeah.
Okay, so Sammy said leave 2x minus y, but then add x dy dx and subtract 2y dy dx. Okay, so now we have terms with dy dx on one side, terms without dy dx on the other side. Trevor, what should we do with the right side?
Factor out dy dx.
Factor out dy dx. So when we factor out dy dx, we're left with dy dx times the quantity, x minus 2y. So to solve for dy dx, we can divide that over and we get 2x minus y divided by x minus 2y. Okay, let's talk about that, Cole. I'm really glad you brought that up. Cole, did you leave the dy dx's on the left side and move the other stuff to the other side? So what did you get, Cole?
Negative 2x plus y over negative x plus 2y.
Okay, you got negative 2x plus y over negative x plus 2y. Okay. These two are actually equivalent. So what happens is if you move the dx's to the right side and somebody else moves the dx's to the left side, your answers are going to look different, but they should be equivalent. Why are these equivalent? Cole, if you factor a -1 out of your numerator, you get 2x minus y. And if you factor a -1 out of your denominator, you get x minus 2y. And those negative ones can cancel out, and we're left with an equivalent answer. Okay? So as you're doing this, if your answer looks different than the back of the book, do this right here. Factor out a negative in your numerator, factor out a negative from your denominator. And if those negatives cancel and you're left with what they have, you have the same thing. Okay? All right. Now, thank you for doing that, Cole. I appreciate it. We were actually looking for the slope at -1, 2. So we're going to take our derivative and evaluate it at -1, 2. Plug -1 in for x, plug 2 in for y, and what is our slope? Okay, -2 minus 2. -1 minus 4. So our slope is 4/5. Cole, did you get a slope of 4/5 with your equation that looks slightly different?
Well, I just did that one.
Okay.
I
So yes. Okay. You should get to the same place.
Yeah.
Questions? Okay. You have some homework. I would look at your gold sheet for your homework. You don't have to write this down. You can look at your gold sheet. Okay. We have about 6 minutes left. So I'm going to pass out your quiz. Well, let's see. You want to just see him tomorrow?
Yeah.